Good morning, good afternoon, and good evening, and welcome to the Friday talk show with Global Electronics and your host, Rajiv Kulkarni. Today's date is May 29th, 2026, and right now the time is 9 a.m. Central Standard Time of US and 7:30 p.m. in the Indian Standard Time. So every week we try to bring in a fresh topic. The speakers may be the same, but we definitely bring in new topics. Sometimes, if my travel schedule conflicts with the timing of the show, that time either I try to premiere the old shows or I just cancel it because of the time constraint. So excuse me for that, but however, we try our best to bring in the best topics that is helpful for the electronics, processing, electronics, manufacturing, electronics, design, and so on and so forth in various types of electronics manufacturing industries. So today's topic is the continuation of the last subject, which is physics-based interface routing, part 2. So in order to speak about that and present the well-prepared presentation is by the veteran, the design specialist, the electronics expert, Mr. Ambaprasad, who is based in Silicon Valley of India, and he has been working in the electronics industry for more than 4 decades now. So welcome, Mr. Ambaprasad. Good evening to you. How are you this evening?
Yeah, doing very good.
Thank you, sir. And thank you very much for your time, as always, because your dedication is very important for the people to learn from the wealth of your experience in the electronics manufacturing industry. And we have been very grateful. The global electronics growth definitely is also dependent on people like you who are ready to share the wealth of knowledge that you have gained in the last several years working in the electronics manufacturing industry. So let's start our topic. The topic is physics-based interface routing, part 2, and I will start presenting. I'll share the screen, and we will start presenting the presentation that you would like to share. Okay, so let's go to your presentation, and here we go with
go to full size.
Full size. Just a second.
Narrow at the top. Yes.
Okay. You can see? Okay.
I can see, and audience also can see. So this
Okay,
is
great.
for basically, usually we start with the last slide of the previous session. So last time I projected 2026 is going to be called as crisis due to AI cycle. And that time also I was very much clear that what we are projecting is true. In fact, a couple of weeks back, I met in one of my training sessions, two of my trainees were company CEOs. They were under heavy pressure from their collaborators to attend our session, and they projected that this is true. It's
Okay.
real. It's really happening. There is a lot of crisis in material, silicon chips, material, PCBs, and even the design time and simulation time used for PCBs related to AI backend. That's for true. So there is nothing unusual about it.
Okay.
In a way, it is nice to be in that industry so that you are occupied. So,
Yes.
but what's happening is the other part of the other verticals also are coming under intense pressure because of this. Okay, go to
Yes.
next
Yes.
slide, please. We are continuing physics-based interface routing. In the coming sessions, I will unravel the difference between interface and interconnection. There is a definite there is a difference between them. And I have titled this as a thin red line between pre-layout and post-layout channel simulation. So we are doing a pre-layout simulation, and then we are going to post-layout simulation, and then we are getting the PCB fabricated. So these are the three issues. We'll go step by step as if we are routing now. So here we talk about a thin red line between pre-layout and post-layout simulation, how they are similar and how they are different. Go to the next slide, please. Agenda. Who is or what is driving faster channels? The thin red line between what if and what about in a channel simulation. Whenever we do simulation, it is only what if scenarios.
So,
And the post layout will be, yeah.
sorry to interrupt. So these kind of the points or the discussion about the physics-based interface routing, these are very helpful for the DFM, DFX engineers.
Yes, exactly. Yes, that's
Okay,
what I was coming
okay.
to.
Okay,
So,
great.
Yeah, basically your ECAD and simulation are tightly integrated using this kind of situation. The methodology remains the same. A
Okay,
few marketing jargons like what if, what about, and all, they have come very recently. But we have done this even 30 years back. Same thing,
okay,
without any
okay.
jargons attached to it. But now these jargons are coming. So this what if scenarios are the sweeps we do in pre-layout, and what about is what we get in the post layout at a CAD level, not even at a fabrication level. At a CAD level, you get what about the results, what happens to that. But now I'm introducing this, I have divided into what if-ary and what aboutery. So what if-ary is, there is nothing called as what if-ary in the world. I only
Yeah.
created it. It may become a jargon little later. But let me tell what is what aboutery. The post layout is all about what aboutery. What aboutery is a word introduced in 1970s by IRA.
Oh,
The IRA introduced this as their language. They told, don't call us so and
well,
so because
sorry
somebody
for
else is also doing so and so.
sorry for my ignorance. What is
Yeah.
IRA?
IRA is they fought freedom. Ireland.
Oh, okay,
They,
okay, okay,
yeah,
okay,
yeah.
okay.
They
I
did
guess
that.
that. Okay, okay, okay.
Yeah,
Let's
it's
not go there.
IRA.
Yeah, yeah. Okay, okay.
It is not
Okay.
another jargon. It is real IRA. IRA means
Yeah, yeah.
IRA.
Okay, okay. Got it,
So
got
they
it.
were
Okay,
telling when in the propaganda they told if someone is doing, we are also doing. If it works for somebody, it works for somebody. And suddenly
okay,
they used to say in their meeting, why don't we do this? He used to say, no, it won't work. It may work elsewhere,
okay,
it won't work with us. So what about
okay,
that is about arguments and counter arguments. So
okay,
the what results we get in a PCB layout, sometimes it works, sometimes it doesn't work. For the same layout, for the same designer, for the same fabrication set, and for the same components. Why this happens? Let's discuss as we go further. Okay.
excellent, excellent.
Yeah, yeah. Next slide.
Yeah,
So here, who is driving the channel speed? For every 5 years, we are seeing the growth, how 100G, 200G, 400G, and 800G is growing. Every 5 years, if you see, a regular business is almost linear, but AI-related traffic is growing by leaps and bounds. That you can see in that yellow
yeah.
line or green line.
Right,
This
right.
is the one which is driving the market. This is closely related to the last slide of our previous session, that the AI traffic
Yeah,
or who
yeah.
is doing a AI business, that is the one which is growing at a faster clip. So
Correct.
go to next slide, please. This is about basically optical networking, 1997 to 2028 projection. We are talking about channel speed and payload. 1.6 T at around 2028 we are hitting. 2026, if you look at the graph, 800G is almost the currency. The channel speed of 800G is right now a normal currency in channel speeds. 400G is history. Even assuming that some of the MSs are backward compatible, but still people will be doing their PCB layouts for 800G throughput on the channel. So that's why this 800G and 400G is going to be our main topic for next 2-3 sessions.
Sessions. Okay, great.
Yeah. Next slide, please. So the architects are going to 800G not because it is faster. If you look at the density comparison, 800G system gives up to 8 terabit. That is about 70% more capacity than a 400G system. And power per transceiver, it is using less power compared to 400G. Two 400G modules is about 44 watt, but one 800G module is about 28 watt. It is roughly about 2/3 less power it is using, 1/3 less power it is using, so which is good. So
And
this is
what is
going
the
to, yeah.
what is the reason of less power consumption? Because when the module is higher, transmitting range, so don't you think the power consumption should be more? Because if the capacity is up to 8 terabyte, so the power per transceiver, why it is less than two 400G module?
Two 400G modules require everything too. It requires, there will be two power supplies inside, there will be two DSPs inside, but 800G will have only one of them. But this 37% less power we are showing only as an ideal situation. But if people take it redundancy into consideration, it may at least 25% can be achieved. It's not a major
Achieved.
problem.
Okay.
Yeah,
Okay.
yeah.
Great.
Why people are going for 800G? It is not a choice for the speed. It is an architectural choice. In the previous slide, we saw system space is less. In fact, in a typical 1U system, using one 800G module, we can use less power, and even thermal management will be very good. We can, instead of using two 400G modules, or even if you want to do instead of using 4 modules, you can use 2 modules like that. It's architectural choice, but some companies are not going for a 1U system because of thermal issues. They go for a 2U system always. Even in 1U it can be achieved. For a better thermal management, they go for a 2U system, which may give them some reverse compatibility or a backward compatibility when they go for the next higher speeds, because the boxes are built for the highest configuration, and the people populate it as it comes. So in our term, we call it is not a forklift replacement. You just replace the cart, that's enough. You don't have to remove the
Right.
entire system. So no forklift replacement is required. And 800G gives you 50%. It consumes 50% fewer wavelength, and it lowest cost per bit because you are using less components, and it is uses lesser power per terabit compared to 400G configuration, and higher density. It gives 8 terabit in 1U, but some companies go for 1U, but some companies have they always go for a 2U system. So it is in the company DNA. They want to do only 2U systems. So that's it. So here even that contradiction I'm clarifying, and this
Okay.
is the right time to take a break.
Okay. We'll take a break here. Stop sharing the screen. Okay. Just a second. Okay, we are right now taking a quick break and then we'll be back. Good morning, good afternoon, and good evening, and welcome back to the Global Electronics Friday Talk Show with your host Rajiv Kulkarni. Every Friday, we bring this podcast or the talk show, 30 minutes to maximum 40 minutes to educate, to share the wealth of knowledge our expert guest they have been experiencing for all those years. And today's guest, Mr. Ambaprasad, who is a veteran in the design industries, in the design of electronics product, in the design of electronics PCBs, for that matter, I would say. And he is sharing with us the his wealth of experience he has accumulated for more than 40 years in the industry. He's based in Silicon Valley of India, which is called as Bengaluru, which is the southern part of India in the state called Karnataka. Today's topic is being discussed on physics-based interface routing, episode number 2. So there can be another couple of episodes based on the same topic, which we will be discussing in the upcoming sessions. And let's welcome, after this break, Mr. Ambaprasad. Welcome back. And let's, I will start sharing the screen. Okay, this is where we left.
Next slide.
Okay.
Full
Oh,
size.
this looks very fancy, beautiful slide.
This slide, let's keep it for some time. Let's the audience digest this. So let them, they will understand what we have put here.
And I want the audience to definitely, if you have any questions related to the topic or any other questions related to the design aspect of printed circuit boards, you can please post it in our YouTube link.
We have only 5 more slides. I think you can keep it on for another 10-15 seconds so that people really understand. And maybe some people have a habit of taking a photograph of this slides and all.
No, the YouTube link is available. They can always go back and have this slide. You know, this it's not anything. We have no issues if people copy this, as long as the disclaimer is very simple. This is not, we are not violating any copyright here, and we are just sharing the information that is available online, and also the sharing the information from our experience, from our guest experience.
Now, this slide has been generated by AI. I used
Yeah,
AI.
exactly. It is available online, so it's not an issue.
So,
okay, let's continue.
Title I gave the thin red line in 112 Gbps PCB channel simulation. On the green side, we are having the pre-layout. You explore, you do your sweeps and predict. This will set your design rules and the constraints manager. And then in the layout, it becomes layout come DFM, whatever we spoke some time back. And that is on the orange side. So green means it is all clear. Orange means, signal lights. Orange means, yeah, you be prepared. That's all. You cannot just click, but be prepared. So that's
Yeah.
like that. This is what we are given. And here still I am at a what about stage. What about area I'm going to hit next episode. That is between the layout and the actual PCB.
Hmm.
So these two I will unravel this. So you can go to next page. Here I'm just explaining what we have shown in the picture. The correlation between pre-layout and post-layout simulation and the workflow. It captures the delicate boundary between pre-layout assumptions, mainly predictive exploration, to design constraints and rules. In a constraints manager, if you put in the CAD, we can verify this. It can be verified. It's not a problem. Once all boxes are ticked only, it will be released for layout, or layout will be released for simulation, like that. That's not an issue. This is a variable and measurable sort of a parameter. There is nothing, there is no black magic about it. Creates a design rule checks and electrical rule checks. Design rule checks are about spacings and whether they are shorting or not. Electrical rule checks are whether they are meeting a timing or the length is perfect and stuff like that. The red line in the center symbolizes the transition from a hypothesis to reality, where a design intent meets extracted geometry and measured in S parameters at your validation stage. So next slide, please. So the pre-layout, it is about what if, purpose, predictive exploration, like what if I change the trace width, what if I change the copper thickness, what I change the dielectric, or what the IC, the driver start switching at a higher speed, all those things. It can be, they can be minimum, optimum, and maximum parameters. People run the simulation. Focus, parametric sweeps, topology optimization, connector model, via model, and equalization. Should we go for a buffer or not? Should we go for a redistributor or a redriver? That's it. Then outcome, a design envelope, eye height, insertion loss, and crosstalk budgets in the constraints manager. If we cannot meet the budget, it will show in red. If we meet the budget, it will show in green. That's very clear. Risk, this is where the problem comes. This is which even I have experienced, and I have misbehaved with somebody. In the people were telling why he is acting like this. He told something yesterday, he's telling something today. This is what happens. If the argument pushed too far, it becomes speculative. Chasing ideal performance, it may not survive a fabrication tolerance. It may meet the requirement in the constraints manager, but it becomes too tight for fabrication. The tolerances becomes very tight, and fabricators, if they cannot meet, I mean, some of them may say you redo your layout, or you change your spec or something. So it has to be really a design for reality. No point in being very idealistic. It is not about fixing numbers. We have to be ideal also. Yeah, that's the best. Next slide, please.
Post layout. What about
Post
that?
layout. This is, I told what about that IRA story I told in 1970.
Yeah.
Arguments, argument between schematic designer and a layout designer, and layout designer versus CAM versus manufacturing versus layout. It's a 360, sometimes it is a 360 cycle in the reverse direction. They say your layout is wrong. So this is what it happens. Purpose, diagnostic validation. What about the impact of a via stub, breakout region, or a skew? Focus, extracted 3D models, actual stack up, and measured S parameters, eye diagrams. Outcome, correlation with a compliance matrix, example IEEE 802.ck iMask, a common analysis, because these masks are available. If you buy I was telling about PDKs last time. In a PDK, these masks are available. It can be cross-checked with it. Risk, if misused or overused or abused, whatever, it becomes defensive, rationalizing poor results instead of correcting the layout flaws. So this is where the waterbotery starts. People act more like lawyers than designers. Next slide, please.
I think we are done
I
today.
think that is the last one. Yeah.
Yeah, that is right.
Yeah.
Okay, great.
So,
Great show, Mr. Ambaprasad.
yeah,
And
we have another 4 minutes. So in the next session, I'm going to show the similarities between simulation and how it works and why it doesn't work sometimes. And
do you
also we
think
can have
are you available for the next Friday? We can continue.
next Friday I'm available.
Okay, let's do that then. So instead of so that the audience can be prepared to continue listening
Prepared
to you on
with their
this.
questions. If they have
Exactly.
any questions previously also, we can cover that.
Yes,
Not an issue.
that is.
But this is
Yes.
like a textbook now. Now already we have a collection of 10 slides. If it becomes a 50 slides or something, it becomes like a textbook. People can refer this. So it's not
Absolutely.
a thing. And one thing I wanted to just convey, compared to last 6 months, now if you go to say any other city other than Bangalore, say Hyderabad, Chennai or Calcutta, people are telling, oh, are you the one who are presenting that shows? They were asking me. So, and I met one person who was my colleague 35 years back. He was on that end of the footpath. I was on this end of the footpath. Then he shouted at me, "Hey, your shows are good."
Oh,
So,
excellent.
excellent. So, even our show is getting a lot of traction.
No, in fact, I should thank the audience and the supporters who are supporting by watching the show on a regular basis, because of that, now we have crossed 1,000 subscribers in less than 15 months, which is not a bad growth at all. And we are growing organically. We are not commercially growing. And as I mentioned, and I keep mentioning that it is a non-commercial channel to help and support the presenters, the guests, also the companies who would like to present on this global platform, because this is being streamed from the United States, so it goes to all over the world. As we distribute the link on LinkedIn around 25 groups, and also to all the WhatsApp members, it gets broadcasted. So that is the result of the growth. I'm saying that in the less than 15 months, we are able to surpass 1,000 subscribers, which is a phenomenal growth. And I think people like Ambaprasad, who is a veteran in the industry, is bringing definitely a lot of value with the wealth of knowledge he is sharing on a weekly basis. Thank you, Mr. Ambaprasad, for that.
Yeah,
So
thanks.
with that, I think we are almost through for today's show and today's episode. I want to thank once again to all the audience out there, and please do post questions if you have any in the YouTube link, and we will be able to answer to you either through the YouTube link or in the next session. And thank you very much. Have a wonderful weekend and take care of your health nicely, so that health is wealth, as we say. Ambaprasad, thank you very much and have a wonderful weekend. Thank you.
Yep.